A security firm just built what they're calling a vulnerability vending machine. You put AI tokens in one end, and a working zero-day comes out the other. And they mean it literally. Their automated pipeline found a brand new, exploitable SQL injection flaw in a WordPress plugin used by over 300,000 sites, and it went from discovery all the way to a working exploit with no human in the loop. Using models you can rent today. Now, the headline sounds like AI magic. It isn't. And this is the part actually worth your time. The clever bit here is not the model. It's the engineering they wrapped around it to stop the AI from doing the dumb thing everyone else does. Here's the mistake. If you take an AI and just point it at a giant codebase and say, find the security bugs, it tries to read every single file. That's wildly expensive in tokens, and worse, its limited attention fills up with thousands of lines of irrelevant code. By the time it reaches the file that actually matters, the real bug is buried in noise, and it misses it. Dumping the whole repo doesn't work. That's the focus problem, and it's why most AI finds bugs, demos flop. Their fix is the smart part. Instead of the whole repo, they use a mature code scanning tool to cut a program slice. Think of your editors, find everywhere this is used. They map every place user input can enter the plugin, then trace just that thread of code, the function it hits, and everything it calls downstream. Basic taint tracking throws away the paths that run through a known safe sanitizer. Now the AI isn't drowning in a codebase. It gets one clean, relevant thread at a time. From there, it's an assembly line. Each code slice goes to a cheap, fast model, Sonnet, to throw out the obviously boring stuff. What survives goes to a heavier model, Opus, which judges whether it's actually exploitable, now with only the relevant code in front of it. And anything that looks exploitable gets handed to a final agent whose whole job is to write the exploit. It can pull up the full source when it needs to, and it spins up the real software in a Docker container to test its attack as it builds it. And it worked. The first bug it vended was a blind SQL injection in a plugin called Creative Mail, 300,000 installs. The exploitation agent one-shot it, wrote a proof of concept that both confirmed the flaw and pulled password hashes and secret tokens straight out of the database. Now, the honest caveat, it only works if the site also runs WooCommerce. But WooCommerce is on over 7 million sites, so that combo is everywhere. Two honest asterisks keep this grounded. First, why it's a big deal. They aimed at the top 200 WordPress plugins, code that bug bounty hunters have already combed over for years. Finding a real zero-day there means the machine can compete with skilled humans. But second, the reality check. This exact bug was also found independently by a human researcher around the same time. So the AI didn't see something no human could. It's not smarter than a good researcher. It's just tireless, and it scales. So here's the real weight of it. This isn't some far future capability, it runs on today's models, and the edge comes from the engineering, the slicing framework, not a magic AI. Which means anyone can build it. Intruder is a defender, turning these finds into scanner checks. But they say it plainly, attackers are already feeding AI the same high-signal input, and that speed advantage is not unique to the good guys. Vulnerability discovery just got dramatically faster. The problem is, patching didn't. That gap is the whole story. When finding a zero-day costs a few dollars of tokens and no human effort, defense becomes a race against a machine that never sleeps. If you want that race called every week, subscribe. Go on, hit subscribe.